Okay, so the project background on digital democracy, the Cal Poly State University has created this project in partnership with some legislative members. They are basically taking a lot of the actions and going on in the Capitol here, and have taken the legislation and done some really neat transcription work with machine learning, along with video and data aggregation. So they've taken a lot of different sources of data regarding these hearings from third parties as well, and have been able to create this really complex database to house it all. And what we're calling, I'll refer to this a lot, but what we're calling the DDDB is their database, which just contains all of the information that they've aggregated from all of these sources. They have their own database team that maintains this, and there's a lot of, it's all very non-Drupal. So this is very, a lot of computer science professors, students that are doing the architecture and the schema for that. And it's a very complex system that requires really a team, the way that they're trying to make sure that the data has the accuracy they need and all the connections with all of the external people that they have, which are actually doing some manual review and also augmenting this data. So they've developed tools with a lot of Python scripts, other UI kind of ways that they're actually getting this data together. So this project came about because their growth plans from this point. They've been they're in this Drupal 7 world on the front end of what they currently have on this project. But what they were trying to deliver is that they want to extend this out to other states, as well as have tiered offerings, for different level of subscriptions. They want to be able to create kind of like smaller portals or white label sites for advocacy groups and organizations, and also be able to kind of start campaigns and other motivational components so that they can deliver this to like a Sierra Club or some specific organization that might want to take just a segment of the site and present it to their members. And then along with that, they wanted to be able to do some advanced compound search queries and those kind of aspects that their current system wouldn't allow them to do. So I'm going to get into their architecture a little bit with Drupal and their other department here. So currently they have this DDDB is located on same server. It's on the same plane, and it's all Amazon hosted. They had built these really complex migration scripts to get everything in nightly from this database into Drupal 7. They're taking all this data into fielded nodes with their own structure, with some schema similarities to what they have, but not nearly of any level. I'd say maybe 10 to 15% of the structure that what they have in the DDDB. So these content types that they did create were very loosely connected. You could not query one portion of their D7 with any entity references or anything or any other ways to actually get to that other data, other than they really tried to combine everything they could into one content type. So it really led to some interesting problems. So yeah, so some of the D7's issues that they've been having up to this point are the synchronization. This is a nightly process that isn't reliable. It's a multi-hour process, and data is actually completely replaced. It's not using any kind of standard Drupal migration module or anything of that sort. They've had a duplication of data. Everything is replicated again inside of their D7 environment. It was really important to them that they would be able to keep this DDDB kind of its own living entity outside of Drupal, because the team managing it didn't want to have those external dependencies or having to rely on a lot of influence from the UI. They really wanted to focus on the data and making sure that the integrity was there without having to do anything very disruptive by integrating a full Drupal team into their team. So given this, they really had a lot of limited Drupal features. Their views, content administration, and search capabilities were pretty very customized. They couldn't just query this piece of information without building an entire migration change into it in order to get it. So schema changes were the other problem. They would be updating this DDDB periodically because new information comes from some new APIs or new other areas, and then that would just cause this cascading effect of a multiple layer of changes. There's this import script, and there's getting into these content types, and then testing and all that arena. So it was not a very friendly system as far as dealing with change. So this is part of their DB schema, which I pretty much equate to this picture that I found. What you're really worried about is when you start trying to just make a small change in there, and actually not break the entire system. You don't want to pull the wrong thing out of this piece, or have your front end completely destroy it. So there's something around like 100 tables in here, but giving credit to the department that's created this, it's a really elegant relationship structure that they've built. I mean, the data, because there's a lot of data that comes in that's like has a lot of unknown or like preliminary data that has not quite all these connections established yet until like a hearing happens or something actually is finalized. They've had to put this stuff into the database, as a temporary measure, and then connect the rest of the data as it goes. So those are things that are really hard to, deal with later down the road. But they've come up with pretty good structure in there. So coming into this project, we had this big choice to make. It was D7 or D8. We put a few different scenarios together. We knew we could deliver. Well, we didn't know for sure. We thought we might be able to deliver a custom entity solution in D7, but given where D8 is at, and that everything is an entity and in its state, we really pushed to go in the D8 direction and try to utilize all of the features that D8 inherently has inside, especially with the effect of doing custom entity work. So some of the use cases for D8 external custom entities is what I'm calling it, which is basically building custom entities around external database tables. Complex external relation databases like this, I think it provides a good way to wrap these without being disruptive. When there's too much data that's changing for periodic migration, which is certainly the case with this project, if you are trying to really utilize that real-time data and you're relying upon a lengthy migration script, there's just no way that you will ever have anything more than maybe a daily update or recent data on there. So DDB schemas with intricate relationships and foreign key constraints. That's another thing we have to carry over, even though we're doing this in D8, but it certainly provides you with a lot more opportunities and different ways to do things using custom entities. Now this isn't essential, but in this case, this really is a read-only database. We are pulling data from this DDDB, but that doesn't have to be the case. You could do the work so that this could be a bidirectional piece of code with your custom entities in the external databases. But it does make it easier because you don't have to worry about affecting any of the data on that side. So what are some of the advantages and disadvantages of using this method? And I'll preface this by saying that this is certainly not the only way to do this. This was pretty experimental on our part to try to actually take in a database of this size and kind of convert it into an entity model. But it's actually seems to be working okay at the moment. We're building, I'd say we're probably about, we'll be delivering some of the site around January, and we're probably about 3/4 of the way there. So one is by using these custom entities in this fashion, you automatically gain all of the Drupal 8 functionality, right? So everything around, views, fieldable entities, all of that is incorporated automatically. We don't have to do any extra work. Gives you some good options for headless Drupal or APIs built on top of these entities. Now and I have examples for a lot of this following. Search API and facets are now readily usable. No import migration process. We're actually saving a lot of time on their development. They don't have to have somebody supporting this import script anymore. So their time can go to development of new features on top of D8. Real-time data, so yeah, no lag in migration. No data duplication. You can also have the ability to do DB replication, which is something that's important, I think, once this scales. So we can actually take, this install, we could mirror their DDDB anywhere we wanted to by just doing MySQL replication. And you get a high level of, customization and overrides inherently from Drupal 8. So disadvantages. Complexity of views, I would say, is one of the biggest things that's happened on this project. We have some insane YAML files that we've exported out of these, order of 1,000 lines. Because you may have a structure where you have 4 tables that have to be linked together just to get one piece of information. Well, you have to reconstruct that in some manner in order to get that data through views. So that comes into play with the configuring of the relationships of this. There's definitely a heavier initial development cost to establishing your custom entities and kind of your architecture. More performance tuning. We're just entering that right now. We're going to talk some caching. And we're definitely we're finding some interesting things that happen when you try to load cascading entities and stuff. Your external database, in the way the model that we've actually done this, it does require it to be on the same server as Drupal. It's not absolutely necessary. There are some ways if you're trying to tie Drupal's information, like not using fieldable or just like strictly doing views on top of this external database, you can actually do some remote connections and set your active database to remote while you're building views and those kind of things. Little more work, but it is possible. And then for local development, you do have to have a way to get your database into your environment, which in this case, it's been a 2 to 3 gigabyte database, so it's been a little bit of a challenge to get your sandbox synced up, but we've been able to work in this manner without too much difficulty because you don't necessarily need fresh data all the time to work on the site. So even if your data is a week old, in this case, it's been fine. Okay, so I'm going to show a little bit of what work we've done with custom entities on this project. So some of the problems and possible issues you might come up with using an external database has to relating to the actual schema itself of what you have coming in. In some of our tables that we had in their schema, we had a lot of tables that would have multiple primary keys and no unique identifier for a particular row, and also non-integer primary keys, which I didn't even realize coming into maybe 2 or 3 entities that we started building. So if you've got a string, Drupal doesn't like that for caching. They want an integer as a primary key. There's been other relationship tables. So there's one table that might have literally 2 columns, right? And all it does is tie this table to this table. Well, do you make that a custom entity, or do you just do some other work behind the scenes to get that information connected? And there's a lot of solutions to that. And then the database not being on the same server as Drupal, as I mentioned before. So some of the solutions we came up with, which we were able to work with their database team without too much, friction, was that any table that did not have a unique identifier, we were able to get, almost in all cases, a column added to at least have some kind of auto increment or an ID for any of that data that was necessary. We just started using some generated columns. So some other things we came across would be like dates. So they've had tables that would use date, time, timestamp, all different sorts of ways to get a date. Year SQL columns. You can use generated columns to create a virtual version of that. So we were able to actually get all those as integers for Drupal to make it less work on that side. And this is something very new to me. I would definitely Google it and check it out if you haven't. But it's only available in the newer versions of MySQL. Computed fields. So in entities, custom entities, you can create computed fields, just like D7, but there are a lot of we're kind of using them in some unique ways here because there's 3 layers that we're dealing with. We're dealing with the entities themselves, like actually the entity load or anything when you actually were just trying to look at an object of an entity, views, and then search API. So computed fields falls into all 3 of those. And then, so SQL views and custom entities built on views. What we had is, in certain situations where we would have maybe 2 tables that need to be joined together, but it wouldn't be worth, or you needed both of those information available in one entity, we would be able to do a union and actually just create a MySQL view on top of that, and then build a custom entity on top of that view. And that's actually worked really well. So rather than creating another table that was a duplicate of like both data combined, you can do a view on top of it, and a Drupal can just consume that as an entity. So some little tricks that we had to kind of come up with on the way on this. And then we are using Drupal database replication to sync the main DDDB over to our production and development servers. So I don't know how many of you have messed with custom entities or gotten involved yet? Okay, cool. So there's a lot of helpful tools, right? We have part of the process here of what we've come up with, and this has been pretty general, but you got to come up with somewhere to put your custom entities. You're going to create some kind of module, but in those modules, it is tricky to figure out what strategy to use to organize them. In the sense of this project, there's a lot of data like for hearings, bills, people, legislators, of all these categories of things. And we would be able to create a set of modules to organize those, by particular function. And then inside of those, we would also drop in related entities for those particular people. We have like a people module, and then legislator entity would go into there as well because they're a person. So it is a little tricky to organize, especially when you have a lot of tables. And then we've been utilizing Drupal Console to do our boilerplate templates. We would right out of the box you can create a content entity, and it gets you pretty far. But once you've got that to a certain point, you have to adjust the annotations. You have to add getters and setters for your fields that you're going to be linking up to your tables. You add those fields to your base field definitions in the entity. And then there's other ways to do this as well, but we chose to do table prefixes in order to actually map those tables to external databases. So by using settings PHP, you can hard override these. So like in this particular case, we have our hearing table just gets a prefix of the DDDB, and that's what our DB name is. So here's an example of some annotation from Drupal Console after generation here, with some alterations that we've done. I'm not going to go through all of this line by line, but I will point out a few things. This is the main item here. So base table is going to tell you where the data is coming from, and then we do have these different handlers that you can override. I'm going to show some more about that. But you can get your right out of the box from Drupal Console. And you do have to define it. These are like your primary key has to be set at minimum. But if you ran this and just changed base table and set your primary keys, you could hit one of these URLs and you could actually see a list of your table. So you would pretty quickly you can actually look at your data that's coming from an external database. I'll have these slides available on the Badcamp so you can put them up. But one caveat, one thing we ran into is that because we're tying to a remote table, Drupal doesn't know that, and when you try to uninstall a module, it wants to erase that table. So you can use services to override this, and this is just one of the things we had to do. So we would, set up a kind of a generic class that just doesn't do anything. It won't. It will just say that it's validated and let you carry on without trying to uninstall. And that's like this content here. So, we have some validation that we're just okay. If it starts with dd underscore or whatever, then for the module, then ignore it. So this is just letting you know that you might run into some situations that are special. Yeah, normally you would, except it takes what's in your config install your in the module itself, which has a schema in it. Okay. We don't have a schema in our config install. Yeah, it's just not in there, so it won't try. So we did get around the install portion of it. So now that this is into the custom entity world, you can take advantage of class inheritance. A lot of database tables in this particular schema had common fields, and this also came into some of their needs of being able to filter and use this data like on a state level. So what we were able to do is we can extend some of the base classes and provide some filtering and add those common fields into one class so that you're not duplicating all of that information across every single one of your custom entities. And then it also lets you override your storage handlers. So you could write a custom storage handler to allow you to do filtering across all of your entities. So for this project, a good example of this is that they started out with just California data, and now they're going to be expanding to different states. So one of the requirements was that we would be able to easily do some kind of context switching and say, okay, let's turn on the New York site. We want all of the data that's pulling to be filtered by New York. So what we did for this is we've got some base classes that we created that extend. So this is, Drupal Console will generate equivalent of this for content entity base. And these are just listing all the fields that would normally be in your entity. So we were able to do a little bit of contextual switching in here, saying like, does this entity have a state column? Okay, if it does, add this, and that just defines a state field for that column. And then here's an example like a hearing entity that's extending that class that's just on the previous slide. So by using the field's parent up there, this automatically gets that state field. And then we just add on what other additional fields that are relevant to that particular table. So that gets you the fields, but it doesn't do any filtering. In this example, so this is on the entity level. The SQL content entity storage handler down here is when you run an entity load, this will actually process and use this class. So by having our entities use this class instead of core, we're putting logic in here to say that, okay, if this is a table that has a state field, automatically add the condition that it only is going to add that where for the state equals New York or California, and it does the context switching that way. But that doesn't do anything for views. So if you created a view on your entity, you're still going to see all the data, because that's only done after the view is actually loaded all of the entities. It runs a SQL query first, and then it loads all of the entities. So we were able to do a views query alter with similar logic, and this will run only on views. So this lets you, when you see the SQL query preview in your views right now, you'll see that it has that, and state equals whatever the current state is. So what's great about this is now every time we add an entity, we're not thinking about, oh, do I need to filter it? Do I need to add it? Do I need to do something special for this case? We just extend the state class if we need to, and it's filtered. So we've all of a sudden added like a multi-site capability without having to create anything except for the initial code. Okay, so after we have created that entity with Drupal Console, all you're going to have initially what are the relationships that you've defined in those base field definitions for views. So you need, if you need additional relationships in there, you have to modify the views data file that's created inside of the source tree. Like I'm trying to see if this comes up here, but yeah. So if you can see the entity here, there's these views data files that are created by Drupal Console. These are what you would augment with that additional information. And I don't know if any of these actually have anything in them. Some would. Yeah, this one does. And I've got some other code examples after this. So that gives you the ability to add relationships to tables that also do not have any custom entities. So there might be a one-off, or like, you know, like I've got this table that I just need a piece of information for, but I only need it for views. I don't really care to create an entity for it because I'm not going to use it ever again. You can do that with just altering your views data. And the other thing that lets you do is it lets you do table joins with multiple conditions, which in the entity itself is a little more tricky. You usually have to do a function or some other way to get that information. So in this example, there's 3 fields here. We have one entity reference, an integer, and a timestamp for the hearing entity. So if I left it this way and I was going to look in views and I want to see relationships available, that's all I'm going to get. I'm going to get this build discussion because it's the only field that I have that's actually defined as an entity relationship. So in this example, this is our person entity, where we've taken this is the views data file, and we've taken a legislator, and we're actually able to add another relationship on the same column that normally wouldn't be available, and you can point it out. So this is the person table. You can create any ID for this to identify it, and these are just defining what the actual field type is in the filters and arguments for views. And then this is the most important part, is that this establishes the relationship. So you can get your base table, which in this case is a legislator. You get your field that we want to join on, and then also the field from the person table, and a label for it. And then this is kind of the resulting SQL query that's generated off of that, which is kind of your standard join. And then once you do this, you clear your cache, you put it through, and this shows a list of all the other ones you've added. But now we have a capability to create that relationship in the view to a legislator. So now that entity's information is available, and we can join that across the view. So if you're not using Search API, which is following this directly, I hadn't included that in the original presentation, but we just started using Search API in the last month on this project. Handling site-wide search is a little problematic if you're trying to search across multiple entities and using views or that. It's, the performance is pretty lacking. Doesn't have those really elegant full text search capabilities, and then not a lot of big data tools, for just using views or that manner. So that lent us into Search API, which has changed a lot. There's been a lot going on with Search API, and we're using Solar as well with this. But a lot of things have changed in the last 6 months of this project. But it's getting more stable. But there's still a lot of quirky things that you have to watch issue queues for. So the first thing off the bat, once we had our entity relationships defined, is that we realized those entity relationship fields become automatically available. And we're using these computed fields also to add additional information about those entities that didn't necessarily exist or wasn't easy to get. That's not really an officially supported thing for Search API. That I have a patch and a little bit of discussion going on because it wants to disable computed fields to be available for Search API to include as indexable fields. And rightly so, because normally they wouldn't be populated, and there's no really checks that the storage engine behind them, is actually good. But if you're using it the way that, in this case, it's not a problem because we're doing stuff in our hook storage loads that take care of that. And then the big advantage is that we're using on this project is that now we've got faceted search available, which lets us build these really great pages that are doing a lot of compound search queries and things of that manner. And this is what I was talking about as far as the computed fields, which if I go back to, see, like this one is a computed field for build discussion IDs. I mean, really it's as simple as setting computed true, but this means that it's not actually in the schema, so it's not in the database anywhere. And you also have a cardinality option, so you could add multiple row references inside of it. You can refer to 5 different entities for that particular case. And then this storage load will run on this entity type of hearing, and like we're setting these committee IDs and we set the build discussion IDs when those entities are loaded. So this means that after this, when you actually do an entity load on hearing on a particular ID, you're going to see all of those fields populated, even though 2 of them didn't come from the database. They're coming from here. And then this is what you get on your Search API fields, which is, I'm really dig this new tree way of being able to add this information. You're able to get your base entity and then relationships through these that we've built through computed fields. Now you can also link to those entities, automatically get all of this stuff, and it keeps cascading. So if I need to get a piece of information about a build discussion, like the start time, I can add that to the search index on here and have any of these fields available right off the bat. And I just index it and it's all available on Facets or wherever you want to use it. So what is the end result of all this? Here's an example of what we kind of created from some of this hearings data. Now we've got faceted search available. We are able to link several entities together using views and embedded views inside of these sections. But now we also aren't doing much custom work to get this presentation. We're just building views on top of those entity relations. So we really gain all those benefits without having to do as much custom work. We're back in Drupal world again. It doesn't feel like we're having to do weird stuff outside of the ecosphere. And yeah, it makes everyone else happy. It makes our themers happy. It seems to be a place where we feel like we can continue development on this, long as not worry so much about the back end once it's established. I mean, here's another simple view, but all of this information before, it was really problematic the way that it was being populated. They would literally have like bills. This whole thing would be one content type, and they would have like JSON fields just listing all of the information for what would go inside of these. So there was no search capabilities on that. It's very hard coded. You would have to do all of the source inside of your page. I mean, some of these pages were over a megabyte to load, just trying to get the information on it. So now we're actually using those relationships and only showing what we need, and the source in these pages is is more on the normal side. And yeah, that's pretty much the bulk of the presentation. Is there any questions?
Can you talk a little bit more about why these externally the same server?
Yeah. So in the case of views, what's happening is that you're actually doing table joins between those two, the Drupal world and the non-Drupal world. So if you're doing fieldable custom entities, those table joins will not work, across multiple servers. There are remote entities and things like that we've been looking into, but a lot of that is so new, and in Drupal 8, I don't know if anybody's really doing it that way yet. There was a lot more work in Drupal 7 on that. But if you're not going to be crossing, if you really are just creating this layer. It's on top of this external database. You could add, some set active database kind of calls on your view so that those tables will just be referenced directly. So you make that view and it will show that data. But in this case, we are going to be combining it with entities that are living on the Drupal side. So we're going to be tying those entity relationships together.
If I understand it right, so there was an existing database, right?
Mm-hmm.
And then you wanted to improve it, and then is the same kind of package database, right? If there were no databases, right, and there was just the idea to do this, what would be the best way to do it? Make the same way, or going the other way?
Yeah.
Creating custom tables on what right now is backend data.
Well, I can say that the easiest way to do that is if those you can still build custom entities and still have them as tables, but if they're living inside of your Drupal, one database inside of Drupal, well, that's the easiest way because there's no external dependencies or anything like that. It's just another table, and that's kind of what Drupal's used to. So the other thing that would happen, I couldn't imagine if you were trying to bring that schema in and trying to create field, one table for every field in there. I mean, it would be insane. I don't know what that would look like exactly, or how it would perform when you're actually trying to join it together. It probably would die. Yeah. So I mean, if you have the choice, I think it really comes down to like how big of a schema do you need to represent. I mean, there's probably the other advantages of keeping it completely external or in its own database. It's easier to back up. Like if you want to back up your Drupal portion and really want to keep the size down, that you can keep that external database the way it is, or a new schema that might be a really sizable database. You might not need your backup strategy might not be as it might be more frequent than your Drupal database, or opposite. I don't know. But, yeah.
So, the first time you were faced with this problem and solution, there was one name that you can see. I mean, there was, okay, why do we use Drupal? Why don't we use something else?
Yeah. Well, they were coming in from Drupal, right? So we were in that sphere. So we knew that we were definitely staying in that arena. We did present A, B, and C. We presented basically another Drupal 7 version with custom entities, and then a Drupal 8 with custom entities, but doing an import process like they were doing. And then the C, which was like, okay, we're actually going to connect to real-time data and build these custom entities around it. And when we looked at the options, we weren't going to gain anything by the other options other than delayed data and some cost of development time. But I think this choice helps them a little bit because they don't have to worry about maintaining another set of data. So that was the savings came from here, where we have a little more development costs, but we were able to bring down maybe the maintainability. So they've already got people take care of this data. We might as well preserve that and not have two teams of people trying to make the same data work. Yeah.
Do you have some example code of how you got the entities to be based off of SQL views?
Yeah, I can probably show one. Let's see. Yeah, this build version current. And let me do this. I actually can probably show this if I have a SQL running here. It was a view. I'm gonna do another one. Okay, so here's one. So this is, I don't know if we can make this bigger. It's pretty tiny, but so this view, current utterance, is based on utterance table, and it has really the only thing it's doing is it's filtering it on. Well, I cut at the end of there. It's filtering on two fields. It's doing current as one and finalize as one, right? So for that one, which is so here's the wrapper for or the entity class for that. It doesn't need anything different other than we're really setting your base table to the view name. All of the fields are coming. Get down to there. All of these fields actually come from just the columns that were in utterance, right?
That kind of just works.
Yeah, you can do it right on top of it. I mean, because it's just doing selects and it's doing standard MySQL queries on top of it, so it doesn't really care whether it's a table or a view. The only things you might have are some performance, variations. As long as your view is performant, then it won't be really much different than using a table. So the only thing is, like in this case, they actually were missing an index on one of those fields inside. So I mean, first time we ran this, we're like, it's not going to work. And then we realized, oh, you're just missing an index. It wasn't anything to do with Drupal. So once the actual MySQL queries are performant, Drupal's just going to run them and populate all the other fields the way it normally would. Any others?
Tell us again about, you said you prefixed the table. Could you go back to that and explain again why?
Yeah.
Why you said that? You had a reason, I didn't get it written down.
Well, so in here, our database is, this is actually okay, so DDDB, right? That's one of our databases that we have inside of it, and then this is the Drupal database. So by prefixing the tables, this is just like pretending, because normally you have a query that would be built on top of your Drupal database, right? So if I did like select star from one of my tables that's in DDDB, like I can't tell if I spelled that right. I got really tiny on here. Actually, let me. There we go.
Nice.
Utter. Okay. So this isn't going to work, right? Because it's trying to select from the Drupal database. It's the wrong database. So all that the prefixing is doing is telling it to do this. And did I spell it right? There we go. So now there's rows.
There are no synonyms in the database.
What was that?
Synonyms.
Synonyms? Well, this isn't actually, like you're talking about for this, what this is doing? Yeah, I mean, this is just telling it the database name dot table name. So there, it's
Synonyms,
like aliases or okay. Yeah, so this is just like really MySQL or SQL layer kind of stuff. If you're
prefixing the table name, you're not. You're just
no, just the actual.
putting the database name in front of the table. Oh, okay.
Yeah, because like the views and stuff, when it's actually querying, is going to be building it on top of the Drupal database. So when it joins a table, it doesn't know that unless you tell it that table is not in that database.
But I thought you said something about in the settings file you accepted a prefix.
This being the database prefix.
Okay.
Yeah.
Got it.
Because
Okay.
prefix you can add to a table.
I was just thinking the prefix.
It's kind of
the
a
table name.
it's kind of a little trick. I don't know if I have a settings file here.
Important little trick.
It is. We have kind of some different ways that we're doing this. We have a routine that actually does it. Like right here, if I let's see what we're doing. But like we have a prefix, which in this case is DDDB, and then we loop through all the tables that we know of that are in our external DB, and we just adding them to the database array on there. Just telling it, okay, if it's one of those tables, just append DDDB dot in front of it, and then it can get to it.
Cool. Thank you.
And it's called prefix, but you don't call it class.
That's just a Drupal thing, yeah. They call it prefix.
Yeah, sorry, I'm so new to Drupal.
Oh yeah. No, it's
Here's an example of this that we can see. I mean, I assume we can't get to this.
yeah. This line's in the slides.
Oh,
So
it is?
what? Yeah,
Oh.
I can have that available.
They have the link of slides again.
I don't have it posted anywhere yet, but I have the PDF. Yeah, I'm going to try to attach it to the Badcamp page for this session. So.
Good stuff.
Yeah. So.
So, do you have like a custom base class that you would use for kind of your intermediary entities, or do you just base it straight off of content?
Yeah, well, we have one for ones that had state fields. I didn't really need it beyond that, but you could. I mean, you could also have everything extend that one class, because we're doing the switching inside of that class to determine if something should be affected or not. So yeah, really, you could build it on top of that, and just in case you decide to add something later to all the entities. Well, if you build it upon some kind of base class, then you have that opportunity rather than editing every single entity. So it's not a bad idea if you think that might happen in the future.
So I think I heard you mention that you didn't create a schema.yaml definition for like all the external database stuff.
Mm-hmm.
Were there any gotchas around not having that there?
No, because you are, by filling in all the fields in the base definition, that's kind of like the equivalent. So while it's tedious, you do have to do that operation once across all your entities. You have to tell it what's in the table. I don't know. I haven't really had any problems other than enabling, disabling modules has been sometimes like some strange error messages might come up, but mostly it was on the uninstall portion. Like we wanted to add a view mode and we had a config volume install. Well, the only way to get that in systems, you got to disable the module and then re-enable it. And that's when we found the database dropping stuff that would happen. So, but if you use a read-only MySQL user, you won't have to worry about dropping your DB.
Do you have any issue with Drupal Console? I know that it changes wicked fast.
Like with Drupal Console itself?
Yeah.
Yeah, we were, I don't know which version we were on, but we're probably about 2 or 3 back when we started doing this. There were a few glitchy things, like particularly with the views data, where like case sensitivity and some of the table names would get mangled when it was trying to, build the boilerplate code. So things like that, we just had to look out for. But in general, it was pretty good. The other thing I'll mention on the Drupal console is like you don't have to use Drupal console to generate all of the stuff for an entity. You only need the actual entity, the file this file. Like here, this is an action entity, right? You actually only need these 2 files if you want to define an entity. All the other stuff is just like other admin stuff, list views, a lot of other things. This would get your entity into Drupal by just creating an interface and then creating this. So in some of these cases, we'd use Drupal console to create the module and create the custom entity, and then we would just copy these 2 files, rename them, and use it for our new entity because we don't need access to any new permissions or like anything. So you could skip the rest of this if you don't really need all that complexity. All right. Well, thanks everyone for attending. And my information. If you have any other questions, feel free to email me. I'm on GitHub, normal places, and I'll get the slide deck up as soon as I can figure out how to do that.
Thank you.
You're welcome.
Yeah. Let's have fun. Cool. No symphony this year?
Oh.